All right, so standard deviation part 1. Okay, we've already established that we need a standard way of evaluating data sets. So the formal definition of standard deviation, a formal measure of how spread out a data set is. The most common way to look at spread is to evaluate a data set using the range. Standard deviation takes into account not just the range, but also the mean, and that's why it is the most conventional way in business and in mathematics to evaluate. So standard deviation compares each item in the data set to the set's mean. Also has the idea of the range embedded in here. Okay? So you're comparing each data set to the mean. So a couple symbols here. So this lowercase, kind of looking cursive O, it's sigma. It stands for standard deviation. So instead of having to write out the word standard deviation, you do this lowercase little cursive O. I already introduced you to a couple of these symbols. X with the bar on top, X bar is our symbol for mean. And also add this in, please. Underneath there is our zigzag looking E, okay, for sum or summation. There are 5 steps for calculating the standard deviation. Okay, we'll use a table to organize our steps, and these are the steps. Step 1, you're going to find the mean of the original data set. Go ahead and fill in these blanks, please. Step 2, you're going to find the difference between each observation in the original data set. In other words, you find how far away each number is from the mean. So difference means we're going to subtract on step number 2. Step 3, some of those when you subtract will be positive, some of them will be negative. To account for that in the equation, we're going to square each of those differences. So step 3, we're going to square each difference. Step 4, you're going to find the mean of those squared differences. So you're going to find the mean twice. And step 5, we're going to take the square root of those average squared differences from step 4. Okay? If you were to Google to look up the equation for standard deviation, it is rather big and intense. However, these 5 steps is what that whole equation means. Okay, so these are our 5 steps for standard deviation. We're going to go through this together twice. Standard deviation, if you said to your parents, hey, I learned how to do standard deviation today, they're going to say, what in the world is that? Okay, it's we all can find the average, we can all square, we can all subtract, we can all take the square root using our calculator. So this is not anything above any of your levels of expertise. Okay, we just have to do these 5 steps in order. And like I mentioned, we're going to use a table to organize our data. Okay, so here we go. With your calculator, the very first step is to find the mean. Okay, so you have your data set 5, 8, 10, 14, and 18. So the mean is when we add these numbers up and divide by how many we have. So I would take and list each number in the first 5. Get my board plugged in. We do have one extra row in our table here, and that's fine. So you're going to list all of the numbers here in the first column. If you haven't yet, I want you to add them up in your calculator. And when we add them up, what are we getting? Our total is 55. Okay? And then directly below that, I'd like you to write your X bar equals. And when we take 55 divided by 5, we get a mean of 11. Okay? Now, the center column there is labeled X minus X bar. So each of these items are called X in the first column. And so you're going to subtract 5 minus 11. What do we get there? Negative 6. Okay, some of these will be negative, some of these will be positive. 8 minus 11. 10 minus 11. 3 minus 11, or excuse me, 14 minus 11. 3. And then 18 minus 11. Okay, so something really cool. This is not one of the steps in standard deviation. I want you to add up that center row. This is a checkpoint. This is 5-step process. You want to make sure that you haven't made a mistake. So add up all of these numbers here in the center. Add up those numbers. Negative 6, negative 3, negative 1, 3, and 7. What do we get? 0. Okay, so if you have not made a mistake, if you calculate your mean correctly and you subtract all of these correctly, you will get a 0 every time. Okay? So in a 5-step process, you don't want to get the answer wrong at the end. This is a checkpoint. Okay? Adding up this row here is a checkpoint. Okay, so step 1 was to find the mean. So if you'd like to write that off to the side, so off to the side is X bar, that was step 1. Okay? Step 2 was to find the differences. Okay? Step 3 is to square each of those numbers. When you square a number, you take it times itself. When you take a negative times a negative, you get positive. So negative 6 times negative 6.
Negative 36.
Positive.
Positive 36.
Negative 3 times negative 3.
9.
Negative 1 times negative 1. 3 times 3. 9. 7 times 7. Okay. So step 3 is to square all of those numbers. Step 4. Step 4. What is it?
Add on the mean of that.
Find the mean of these squared differences. So go ahead and add those up, please. We added all these numbers up, and we're getting 104. 104. Okay. So step 5. Oh, we're not quite done. That's just the sum. What do we need to do with 104?
Divide by 5.
20.8.
Okay. Now, I highly recommend that you leave step 4 as a fraction, okay, if it doesn't work out to a perfect number, like a whole number. So did we get exactly 0.8?
Yeah.
Okay, so 104 divided by 5, you get exactly 20.8. But let's say you divide this step 4 and you get a long decimal. I highly recommend not rounding, because then step 5 is to take the square root. Okay, so step 5 is to take the square root of step 4. So in your calculator, this is what we can type. So in your calculator, you would want to hit second square to get your square root symbol on the graphing calculator. But I need everyone to find the square root symbol on your calculator. So you can take the square root of 104 divided by 5. You can type it in all together. In this case, we got the 20.8. You could type 20.8 because that's exact. But the square root of 104 divided by 5. Okay, I will assist you if you need help finding the square root button. Raise your hand, please, if you need help finding it.
I got 0.
Well,
We will round standard deviation to the nearest hundredth. Okay? Follow the directions on whatever your worksheet or quiz says, but we will round the standard deviation to the nearest hundredth. So remember, in our calculator, on step 5, we typed in the square root of 104 divided by 5. And we get 4.56. And again, that symbol is your lowercase cursive O that you can use. So lowercase cursive O equals 4.56. So if you would flip over to example number 2. Let's go through another example together here. So the data set on example number 2 is 11, 19, 15, 9, and 11. It doesn't matter which order you type or you write these in your table. You can fill them in straight down. Some students prefer to put them in least to greatest. That's your choice. So I'm going to go ahead and fill it in 11, 19, 15, 9, and 11. Okay, step 1, add these numbers up and divide by, again, 5. So we're going to add these up. We should get a total of 65. Divide by 5. So our x bar is 13. So that's step 1. Step 2 is to find the difference. So again, this table kind of shows you, hey, what's going on here? What's your next step? So once we have our 13 here, let's subtract 11 minus 13, negative 2. 19 14 minus 13 is a positive 6. 15 minus 13, that'd be a positive 2. 9 minus 13 would be,
Negative 4.
and 11 minus 13
Negative
is our negative 2. And again, that checkpoint, if we add up this center column here, okay, I can see I'm getting 8 here and negative 8. So again, my sum here is 0. Not a part of standard deviation, but a checkpoint to know that, hey, we got the mean right and we subtracted all of these correctly. Okay, so if you would please go ahead and square each of these numbers and find the mean of that last column. Remember, when you are squaring, you should get a positive number. In this third column, all of the numbers should be positive. Let's go ahead and see how we're doing here. We should have 4, 36, 4, 16, and 4. Step 4 is to find the mean of this last column. You want to add them up. We should get 64. We're going to divide by, again, 5. Again, when we divide by 5, we do get a whole number here, or not a whole number, but a decimal that ends that 12.8. But on step 5, I highly recommend getting used to just typing this in as a fraction. So step 5 is the square root of our mean, which would be 64 over 5. And we're going to say, so standard deviation equals, we're going to round to the nearest 10th, or excuse me, to the nearest 100th, and we should get 3.58. Now, notice we have 3.58 as our standard deviation, 3.577. That's why we're rounding up to the 5/8. You look at the third decimal place there. All right, 2 examples to kind of evaluate here. To finish up, example number 3. Mrs. Dinkel's second hour class has a test average of 88. The standard deviation is 11. For 7th hour, the test average was 90, and the standard deviation is 10. Which class had more varied test scores? So standard deviation, the official definition is how spread out the data is. So second hour has a standard deviation of 11. 7th hour has a standard deviation of 10. So second hour, okay, second hour is more varied data. It has a higher standard deviation. second hour is more varied, and we know that because the standard deviation is higher. All right, and example number 4. A track athlete has an average 800-meter race has an average of 2 minutes and 57 seconds, the standard deviation of 2. Another track athlete has an average of on the 100-meter dash of 11 seconds, and the standard deviation is 2 seconds. Both data sets have a standard deviation of 2. So both data sets are equally varied and spread out. But we want to talk about that a little bit more. So they both have a standard deviation of 2, okay? But think about how much time is elapsed during that trial or experiment, okay? The first athlete has a standard deviation of 2. That's 2 minutes and 57 seconds with a 2-second vary to the left and to the right. That is not a lot of variation. This is not a whole lot of variation. On the other hand, a 2-second standard deviation, when your average time is 11 seconds, 2 seconds compared to 11 is quite a bit. 2 seconds on 11 seconds is quite a bit of variation. 2 seconds on 2 minutes, almost 3 minutes, is not. So that student or that athlete who's running that 100-meter dash, you would think that short amount of distance, that short amount of time, you would think that standard deviation should be smaller, okay? And that's the type of thing that you're going to want. Now that we have standard deviation, we're still going to have to analyze some of these situations, okay? So, just so you have an idea of how cool these 5 steps are that we're doing and you understand, okay, I think when we were going through that second step, you were like, oh my goodness, she said the standard deviation is some massive thing. We have these 5 steps that we're going through. I'm going to show you how in math, this formula, how those 5 steps are abbreviated into just symbols, okay? So if you want to write down this formula at the bottom so you can show it off, you can. You will never have to write this formula again. I'm never going to ask you to memorize it, but this is the formula just in symbols.
E equals
Okay.
MC squared.
What?
E equals MC squared.
Not quite. So standard deviation.
Equals minus 47.
So it's a rather large square root symbol because there's going to be a fraction underneath. Okay? So in the standard deviation formula, you have to add up all of that data. And remember how we said there was x pieces? We can also call that an n. And we have this little I equals 1. And what are we going to sum up? We're going to sum up all of those x's. We're also going to subtract each of those x's minus the mean and square them. And the last thing, once we had all that total, we had to do what? We had to find the mean one more time. So we had to divide by n. So I don't know about you, but if I was a freshman in school and I looked up how to do standard deviation, and this massive equation popped up on the screen, I'd be like, I don't think so. I think I'm going to not do this. But just remember, okay. So just remember that those 5 steps that we wrote down, okay, all of these 5 steps right here, that can be abbreviated with these symbols and numbers right here.
Is that a 1 like below the?
This is a little I equals 1.
No. Below
This is a x sub 1, yes. Basically what that's saying is start with the first one in your list. Start with your first one in your list and then go down your list. That's all that's saying. Okay?
So we're basically just doing the deviation that we've been doing, like the 64 minus below by 5.
Mean.
Yeah.
Mm-hmm.
So we're basically doing that plus or times the original
So it's the mean minus each data point,
So it'd be
squaring them.
So for the 11, 19, 59, and 11, so it'd be 3.58 times 65, and then I equals 1. And then you divide by n.
Well, when you divide by n, you get your 3.59. That's the answer at the very end. Yeah. All right, so that concludes our notes for standard deviation part 1.